Hello everyone. Today we are going to start a new topic called electromagnetic wave. So we are starting a new topic after electromagnetism and electromagnetic induction, also after AC current or alternating current. So today's topic is electromagnetic wave. Wave. Here at first we will study a new concept, the concept of displacement current. What is displacement current? Till now, we have studied about the conduction current, but now we are going to start a new concept which is displacement current. current. To understand this topic or this concept, uh, at first I am going to take a capacitor and we are connecting this with a battery and a resistor. Here these two yellow straight lines are the parallel plates of this capacitor, and let's say this is a battery of V volt and this is a resistance of R ohm. We know for a conducting wire, the current flows due to the flow of electron. If we say the current is flowing from this direction to this one, then you can denote it by I. But we know electron is flowing from its opposite direction to its opposite direction. Now it is clear that the current through this conducting wire is due to electron. But for a capacitor, there is no conducting wire. So there is no free electron which can give us a conduction current. That means we can see it IC for conduction current. Then if we make a circuit like this, how can I say if there is IC current, we will get here also a IC current. We can say from Ampere's circuital law. We have studied in electromagnetism. Electromagnetism. What is Ampere's circuital law? Ampere's circuital law says us Ampere's circuital law. For a closed loop, integration of B dot dl equals mu naught IC, where IC is the conduction current. But for this capacitor, for this zone, the capacitor zone, there is no IC, but there is a magnetic field and it is violating the Ampere's circuital law. When Maxwell studies this one, Maxwell give us a great learning. What is that? Maxwell says us this is not there is a current which is actually equals to IC, but we cannot say it as IC. I mean conduction current. So it is clear this is there is a current flowing from this direction to this direction. But this is not due to the electron. So what can I say this current? Then Maxwell named it as displacement current. So the Ampere circuital law becomes modified by Maxwell, and it is named now Ampere Maxwell circuital law. And it is like that: the closed line integral of B dot dl is equals mu naught IC plus ID, mu naught IC plus ID, where ID is epsilon naught d phi c by dt or d phi e by dt. Here phi e is electric flux, phi e is electric flux, which is nothing but the integration of E dot ds. Now, the main concept behind the electromagnetic wave, the changing electric field in capacitor. I mean, how the capacitor becomes charged. At first, if we make an open circuit capacitor, I mean, if I take a capacitor and connect with battery and a resistor, now it is open, there is no connection. Therefore, we can say at first for time t equals 0, there is no charge stored in this capacitor. But if we connect the lines, I mean, if I close the switch, then what scenario we will get? We will get, if this is a voltage, this is a battery of V volt, then the positive charges will accumulate in this side, and with respect to time also, it is accumulating with respect to time, and there is a negative charges accumulating this side with respect to time. Now, if we see for a single charge, for a single plus and minus, there is an electric field. Now, if we increase the charges, then the electric field also increases. Now, if we increase with respect to time, it is increasing charges, then the electric field lines also increases. That means electric field is being changed with respect to time. So, we can say here we will get a electric field, which is changing with time. We can see by a demo. Please take a look. Here we have a capacitor lab. So, here at first this is a discharged capacitor, there is no charge on the plates. I have taken a battery of 3 volt and a resistor of 5 ohm. At first I equals 0, that means the switch is open. Now I am going to close the switch. Please see what we will get. Resistance. Okay. Now I am going to close the switch. See how it is accumulating the charges on these plates, and the electric field lines we can see is increasing with respect to time. And for what time it is going to show us this scenario? The scenario will see up to the voltage of the capacitor equals the voltage of the battery, potential difference. So we can see if we take one more time, at first open the switch and discharge the capacitor. Now again I am going to close the switch. Please take a look with more concentration. See how the charges are being accumulated, and the electric field line also increase with respect to time, and the capacitor voltage becomes the equals the voltage of the battery. This is how the electric field is changing with time. Now, according to the Biot-Savart's law, if there is a current or there is a electric field, it will create a magnetic field. So we can say if there is a changing electric field, it will create a changing magnetic field. Now we can say the changing electric field E equals E0 sin omega t minus kx, and it will create a magnetic field which is nothing but B equals B0 sin omega t minus kx. Okay. And these two fields, these electric fields and the magnetic fields, both are in perpendicular to each other. That means if we draw electric field along this side and magnetic field along this line, and this is a vector perpendicular to both of them, then how the electric field is going on? Like that, and the magnetic field is going like that. And the electric field length, electric field wave is like that. Okay, these two waves, when these two waves superimpose or superpose, we can say it will create a new wave which is going along the perpendicular to each other, perpendicular to both of these vectors or waves. both of these vectors, and this is the new wave which is called electromagnetic wave, which has a term, electrical term and a magnetic term. This is electrical wave, electrical portion, and this is magnetic portion. And by superposition they creates a new wave perpendicular to both of these, which is traveling along the s axis. We can say this is y and this is z also. Then we can say these two vectors or these two waves are superimposing and creating a new wave which is called electromagnetic wave. Okay, thus this electromagnetic wave is created. Here k is the wave number and the omega in both cases, omega is angular frequency. Angular frequency. Thus the electromagnetic wave is created. Okay, here we will stop the first lecture of electromagnetic wave, and for next class we will going to start the energy density of a electromagnetic wave, electromagnetic wave, and the pointing vector concept. So